All right, so this is a continuation of the test, Chapter 11 test review of the Quiz 1 topics from Algebra 2. So in the next one, we start out with our word problems. So if $12,000 is deposited in an account paying 8%, compound it continuously. Now remember, when you're doing these word problems, the important piece at first is to identify, is it compound it continuously or at a set amount of time? So continuously tells me we're going to use the formula A equals P e to the RT. Otherwise, we'd have to use the A equals P 1 plus R to the NT. So that means I need to identify what's my A, what's my P. The E is a number, so we don't have to worry about that. What's the R, what's the T? So $12,000 is deposited. A deposit is the principal amount or the starting amount, so that tells me that's my P. In an account paying 8%, so 8% is my rate, which would be 0.08. How much will there be in 10 years? So my time is T, so I don't know my A. So A equals 1200. E to the R, which is 0.08, times T, which is 10. So now, since A is already by itself, we can go ahead and just type this into our calculator. So 1200 E to the 0.08 times 10, which gives me 2670.649. Now we're talking about money, right? Which means we're going to round to the two places after the decimal. So that really becomes $22,670.65. Now remember, since this is a word problem, we have to write a sentence in words. So I would say, in 10 years, remember that you need to put the time, because if it were a different amount of time, the amount would be different. So in 10 years, there will be $2,670.65 in the account. Now, if I asked you how much money he had made, that would not be how much he made, right? Because he had put $1,200 in initially, so I would have needed to subtract these to figure out how much he made or how much he profited. Okay, but this is the total amount he had at the end, including his initial deposit. All right, so now we're going to move on to the last page, which is all about the graphing. So every time you're doing this, you're going to be asked to find domain, range, list the asymptotes, create a table, and then of course you also need to graph. So right away, I notice that this is exponential because we have an exponent with a variable. So as soon as we see a variable in the exponent, we should realize this is exponential. And remember, there are different properties for exponential versus logarithmic. So since this is exponential, I immediately know the domain is negative infinity to infinity. If it were logarithmic, then the range would be negative infinity to infinity. Then I need to think about the range, which I'll do after I graph it and after I find my asymptote. Now in this case, remember, since it's exponential, we look at the last number to give us our asymptote, or the thing added, I should say, or subtracted at the end. And this gives us a horizontal asymptote, so we say y equals whatever that number is. So my horizontal asymptote is at y equals 3, and I can go ahead and go to where y equals 3 and make a dotted line, because remember, part of your graph is having the asymptote in there to remind us that the line should approach our asymptote but never actually cross it. That tells me that 3 will be part of my range, but I'll graph it in order to figure out what part. So I'm going to go ahead and make my XY table, or my XY table over here. When I do that, we're going to go to our graph, right? Go to y equals and type in the equation. To the negative 2x, arrow out. Make sure you remember to do that. We can go ahead and graph it to get an idea of what it looks like. So it looks like it's at the top and then approaching that. So based on this alone, I can tell that my y is positive infinity and 3. 3 is my lowest, so we'll write our 3 first. And remember, we have to do a parenthesis because it never actually touches 3, it just approaches it. And then since it's going towards the positive direction in the y, that means positive infinity. Then we can go ahead and go to our table. And remember, we said the y should approach 3. So when I scroll up and down, I'm going to look for where y approaches 3. Well, right here is where y is 3-ish, right? It keeps getting closer and closer to 3, so that's where I need my table to go to. So I can start off, I don't know, around -2. So -2, and it's about 58, which I won't be able to put on my graph, but that's fine. -1 and 10.4. 0 and 4, 1 and 3.1, and then 2 and 3.02, and I'll stop there because that's getting really close to 3 without touching it, and then those are the points I need to graph. So -2, 58, I'm not going to bother doing, but -1 and 10.4, I can go ahead and do. 0, 4, 1 and 3.1, and then 2 and 3.02, and now we can go ahead and kind of create our curve going through this and approaching it. Remember to put our arrows at the end to show that it keeps going in that direction. Okay, so the next one we're going to look at is a logarithmic graph. The beginning part is the same idea, but you have to realize that since it's a log, right, that means that my range is -infinity to infinity, and my domain is what I'm going to have to figure out based on my asymptote. Now, because it's a log, we look at what's inside the log to determine the asymptote, and we just set the inside equal to 0, so x equals 0. There's no need to solve that, so that just tells me that my vertical asymptote is at x equals 0. So I can go ahead to where x equals 0 and create my asymptote. Now, since that's right on the x-axis, I would make that really thick or somehow really visible so we can see where that line is, whether it's using a different color or making a thicker line or using a highlighter. Now, this also tells me that that's going to be part of my domain, so now I need to graph it. The issue is, if I'm going to type this into my graphing calculator, I can't type in log base 1/5 because our log is assumed to be base 10, so we have to do the change of base before we can type it in. Which means we really just do log of x over log of the base, which is 1/5, and that's what y equals when we type it into our graphing calculator. So log of x, make sure you end your parenthesis to say that log is done, divide it by log of 1/5. Now we can graph it to get a general look. So we're talking about domain, which is the x values, right? So x value, we have 0 on one end, and x is going towards positive infinity on the other. So this would be from 0 to infinity for my domain. And then I can go ahead and go to my table to start making my XY table here. And we see these errors, so we know we're going to ignore the errors. I'd probably put the first error down to show that that was an error. And then 1, 0, 2, -0.43, 3, -0.68, 4, -0.86, 5, -1, and 6, -1.1 should be enough. So now we're going to go ahead and graph those. So we don't graph anything at 0, but 1, 0 is here. 2, -4.3 is a little bit less than half. A little bit more than half for 6.8. getting really close to -1, and then at 5 we're at -1, and then a little bit beyond that. Now remember, a lot of you want to just kind of make your line here and then stop. However, it does approach 0, so even though on the graphing calculator it doesn't show it, you still have to extend up and show getting closer and closer to 0 as well. All right, last one. So again, when we look at this, we should note that this is exponential because we have an exponent for a variable. And as soon as I see that it's exponential, that tells me my domain is going to be -infinity to infinity. My range will come from finding my asymptote. And remember, the asymptote should come from what's added at the end. Well, nothing's added at the end, so we can just say y, oops, sorry, that's not the range. My asymptote is y equals 0, so that's my horizontal asymptote. So we can go to where y would equal 0 and create our line for our asymptote. Then I can go ahead and take out my calculator again, go to the y equals, clear it out, and type it in, right? So 1/5 to the x power. Now, if you use the fraction button, then all your table values will be in a fraction form. That's why I don't use the fraction button here, because I'd rather graph a decimal than a fraction. So let's look at our graph here so we can determine what our range is. So range, remember, is y's. So we're looking at positive infinity because it's going up. And 0 is the smallest, so that means 0 to positive infinity is my range. And so when I go to look at my table, I'm going to want to find approaching where y approaches 0 and then go for the other numbers. So this is where y is approaching 0, so I'd probably scroll up. And I think 0.008 is good enough, so I can't graph 125 on here, so I'm not going to list that. 25 also will not fit on this graph. So the first one I'm going to list down for my x is -1, 5, 0, 1, 1.2, 2.04, and then 3.008. And we can go ahead and put those on our graph. So -1, 5, 0, 1, 1.2.04, so we're getting really, really close without touching 0. So we're going down something like that. Oop, shouldn't go up, should stay pretty close. All right, just make sure you're reviewing even the stuff from the quiz we just took to prepare for the test.